All right, so welcome back. Um, Today we are going to solve quadratic equations using square roots. So you don't have this warm-up sheet in front of you, but you can just kind of follow along as I do it. The other thing you'll want out besides your notes for today, which those are the ones that have the easy button on them, also that sheet that we talked about yesterday is the 4 ways to factor. So we filled in yesterday the graphing one, and then there's also quadratic formula and factoring in square roots. So we're going to use that at the end of this lesson and fill out the square roots one just so we can continue that graphic organizer. Okay, so remember to solve equations, which we really haven't solved like equations per se in a while. So you have to remember that concept of SAD map, right? So reverse order of operations. So when solving equations, you get rid of subtraction or addition first, and then division or multiplication second, and then exponents, and then parentheses. So for like number 1, you have multiplication, you have addition. So you would first subtract 4, and you have 3x equals 9, and you divide by 3, and x equals 3. And you're like, this is super easy. Why are we doing this again? Well, because we're bringing in a new concept to this today. So number 2, add 1, 6x equals 18, divide by 6, and x equals 3. Number 3, same sort of process. Subtract 2, you have 1 fourth x equals 5. Now, remember, to get rid of fractions, so this is really just 1 times x divided by 4, so you can just multiply by 4 if you want, or you can always multiply by the reciprocal. So that cancels out here, you get x. Well, so 5 times 4 over 1 is 20. Here we have x divided by 5 for number 4. So I multiply both sides by 5, and I get x equals 60. Okay, so then with number 5, I would add 9, and I get 5x equals 25. I would divide by 5, and x equals 5. Okay, so number 6 is a little bit strange because we've only really solved linear equations, right? So we haven't solved any equations per se that have like a squared or a cubed or something like that. So remember, you get rid of things by doing the opposite, right? So like in number 5, we wanted to get rid of this minus 9, so we added 9. We wanted to get rid of multiply by 5, so we divided by 5. So you have to think, well, what's the opposite of squaring something? And if you're shouting from the back here, take the square root, you are correct. So we have x equals, well, square root of 16 is 4. However, you're right. We have to have this idea of plus and minus 4. Because remember what it means to square something, right? It's multiplied by itself. So 4 squared is 16 because 4 times 4 is 16. But guess what? Negative 4, if it's in parentheses, squared is also 16 because negative 4 times negative 4 will give you a positive 16. So we have to have this little plus or minus in front anytime that we take the square root to solve something. So this is what we're doing today. We're just solving equations that look like this, maybe slightly more complicated. Okay, so this is like the easiest way to solve quadratic equations. However, it only works in like one instance, and it's that you have no b term. So remember that ax squared plus bx plus c, you cannot have that. So you can only have ax squared plus or minus c. And then a bunch of other things around it, whether it's parentheses or blah, blah, blah. But you can't have an x term because you have to be able to isolate just one variable. So the first step in any of these, you isolate the x squared term. So that's where you do all of your equation solving. You get rid of addition by subtracting, you get rid of multiplication by dividing, blah, 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 blah. Okay, so isolate the x squared term. Step 2, take the square root on both sides. Remember that plus or minus. Step 3, round to the nearest tenth. Because not all of these are, when you take the square root, if you take the square root of 1 or 4 or 9 or 16 or 25, etc., then you're going to get a whole number. If you take the square root of anything else, you're not going to. So that's when we just say round to the nearest tenth, unless directions tell you to round to a different thing, like the hundredth or whatever. All right, so we're going to look at this first row right here. So the first row, we don't really have to do this step 1, right? So does the x squared term, that's all I have. So all I'm going to do is take the square root on both sides. So square root of x squared cancels out, and I get x equals plus or minus 5. Now number 2, I'm going to throw you for a loop here, because if I try to take the square root on both sides, you can't take a square root of a negative number, right? So like the square root of regular 64 is 8. But there's no 2 numbers that you can multiply together to get a negative number that are the exact same as each other, right? So if I have 8 times 8, that's 64. And if I have negative 8 times negative 8, that's also 64. So if I'm taking, like if I'm squaring something, I'm multiplying the exact same thing by itself. So I can't have 8 times negative 8 because 8 and negative 8 are not the same number. So you're like, well, what do you do now? Well, you can't take the square root of a negative number. It just doesn't exist in a real form. There is an imaginary number that goes along with it. So the answer to this is actually 8i, but that doesn't matter right now. Your answer, remember the pirate speak from yesterday, is narn. Narn, not a real number. So if you ever get to a point where you're taking a square root of a negative number, your answer is always narn. Because there is not a real number that exists that you can square to get to a negative number. Now, I caution you to be careful with this, because if you just see a negative number, make sure you don't have anything else you have to do first that would make it positive, such as like dividing by a negative or something. Okay, moving on. So number 3, again, my x squared term is all by itself. I'm going to take the square root of that, and I get x. And then I do the square root of 80. And I know the square root of 81 is 9, so it's going to be pretty close to 9. I'm stalling while I get my calculator. Square root of 80 is, hold on. So x is, let's go approximately equal to plus or minus 8.9. Okay, so easy enough on those, right? Good. It's nice when you're not here, because you can't say, no, I don't understand the calc. Good, we're again. All right. So this row is where we have to employ this idea of, doing something first. So I can't do anything with this term until I have it by itself. So what is stopping x squared from being by itself is this 3 right here. So I'm going to have to divide both sides by 3 first. So I get x squared equals 9. Now my x squared term is all by itself on the left, so I can take the square root, those cancel out. Square root of 9, of course, is plus or minus 3. All right, so same thing here. And this is kind of what I was talking about when I referred to this problem. Like, be careful. If you just see a negative, you're like, oh, I'm going to take a square root of a negative number. That 125 is negative, so it's narn. It's not narn, because you have this being multiplied by negative 5. So you have to divide first by negative 5. And you got x squared negative 125 divided by negative 5 is positive 25. So now x squared is all alone. I can take the square root of it. So I get x equals plus or minus 5. All right, number 6. 10 is being multiplied by x squared, so I have to get rid of that 10. So I get x squared equals negative 400. Okay, well now if I take the square root, I will be trying to take the square root of a negative number, and we can't do that. So this one is narn. All right. The last step in here, or the last row, excuse me, just has you doing like one more step to it, right? So this just looks like, again, regular equations, like pretend that square's not even there, like you already, of course, know how to solve these. So number 7, you have 0 equals 81x squared minus 25. All right, so I've actually x squared, being multiplied by 81, and then also minus 25. So I'm going to get rid of my 25 first. So 25 equals 81x squared. So now I'm going to have to divide both sides by 81. And at this point, you have two options, okay? So I got x squared equals 25 over 81. If you are good at your perfect squares, you should notice that those are both perfect squares. So if I do take the square root on both sides, then I end up with x over on the right here. And then plus or minus square root of 25 is 5, square root of 81 is 9. So that's one way I can do it. So if they work out to both be perfect squares, that doesn't always happen that way. Otherwise, you can just put it in your calculator. And if you do the square root of 25 over 81, or just simply do 5 over 9, you get 0.5 repeating. So you could also have plus or minus 0.5 repeating. Okay. Moving on. Number 8. So I have 3x squared minus 4 equals 23. If I add 4 to both sides, I get 3x squared equals 27. I'm going to divide both sides by 3. And I get x squared equals 9. Take the square root on both sides. Cancels out with my x. And I get x equals plus or minus 3. So I tried to give you kind of nice ones. Most of them work out in numbers. All right, number 9, last one. Add 20. I get 4x squared equals 25. Next step, of course, I'm going to divide by 4. And the same thing that happened over in number 7 is happening here, where it's like, oh, 25 over 4, do I really look like this? It's obviously 4 doesn't finish 25. However, again, the square root of 25, or 25 is a perfect square, so it's 4. So I could do x equals square root of 25 is 5, square root of 4 is 2. Or, and then of course you need plus or minus, which I tend to forget to. Or it could also be plus or minus 2.5. All right, so like honestly, like that's it for notes. So that's all we really need. I told you it was easy, right? That's why I put the easy thing on there. And hold on, hopefully this picks up on my microphone.
That was easy.
There you go. So if you didn't hear that, I hit the easy button. All right. So go back to that sheet that we had yesterday, the 4 ways to solve one. So this is option 3, because I usually teach it third, but since I'm gone, it's actually quite a bit easier than the quadratic formula, and I want to be here to teach you quadratic formula, so we're doing option 3 for option 2. So when this works, well, remember I said you can only use it when you don't have a B term. So like no regular x, if you want to think about it that way. So you can have, obviously you need an x squared, that's what makes it quadratic, but you can't have just regular x. So how you would solve just like a regular equation, solve like regular equation. So that means like using, say, add math, right? And then take the square root on both sides once you isolate your x squared term. So after x squared by itself. And don't forget, answer is plus or minus. And then that last thing, of course, is if we take the square root of a negative number, it's narn. Because that number does not exist in any real form. So it's not a real number. All right, like quickest lesson ever, right? All right, so you have homework tonight. It's at CUDA, solved by square roots. And it's front and back, but it's just, again, like super pretty basic equation solving. So Good luck with that. And I will be back tomorrow, and so I will answer any and all questions that you have before then. But if anything was confusing about any of this stuff, I really encourage you to watch the videos again and like see if you can kind of go through like a little bit slower once you've seen it already, and see if you can process it a little bit more. All right. I will see you guys tomorrow. Goodbye.